This is a rate law problem. We're given a balanced chemical equation, and we're told that the rate law was determined via experiment to be second order with respect to NO concentration and first order with respect to Br2 concentration. So the first question is to determine what will happen to the rate if NO is tripled and Br2 is doubled. So here the second concentration of NO is 3 times the initial concentration. Note these subscripts indicate which trial is being referred to, and the bromine concentration in the second trial is twice that of the first trial. So all we've done here is applied the rate law to trials 2 and to trial 1. And in each case, the rate is going to be equal to K times the concentration of NO squared and the concentration of Br2 raised to the first power. And these subscripts here refer to the trial that's going to be involved. So we're going to compare the rate of trial 2 to the rate of trial 1. All right, so here we are comparing our rates of trial 1 and 2. We see K cancels, and we also see the concentration of NO of trial 1 squared is going to cancel out, and the concentration of Br2 in trial 1 is going to cancel out. Now here we want to be very careful because we see this 3 is inside the parentheses that needs to be squared. So when we cancel out these concentrations, we need to be careful to note that 3, that entire quantity, has to be squared. So we have 3 squared is equal to 9 times 2. Our ratio of the rates is going to be equal to 18. All right, so here we have it completely worked out. Our rate 2 to rate 1 is going to be equal to 18 to 1. So rate 2 times 1 is equal to rate 1 times 18, or we rearrange it, and we see that our second rate is 18 times faster than our initial rate. All right, to find units on K for any rate law, let's first remind ourselves that rate of a reaction is given as change in concentration per unit time. So it's usually moles per liter per second. Occasionally you see some other unit other than seconds. All right, so we plug in the rate law that the rate is equal to K times NO squared Br2 to the first power. So if we solve for K, we see K is going to be equal to the rate divided by concentration to the third. All right, and here we have it all written out, and let's just look to see what cancels. The moles cancel, one of the liters cancel, and we can write out our units. And here we have our final answer. K is going to be given as liters squared over moles squared per second, or liters squared times mole to the minus 2 times second to the minus 2.